And where we were at in this question is we were just in the simplifying mode. We had found out it was term 4. We have to simplify the rest of this. So when simplifying here, we're going to have that exponent be a 6, so you need to figure out what 3 to the 6 is. 729. X to the 12 to the x to the 2 to the 6 will be x to the 12. And the last one, negative 2 cubed, will still be negative. It'll be negative 8. And the x will be cubed as well. Now when we multiply our numbers together, we get negative 4, 8. I'll just move my cursor so that those aren't all showing. Negative 4, 8, 9. 8, 8, 8. And the x of 12 will simplify with the x to the 3, which gives us x to the 9. Now, if we look at the original question was, find the term containing the x to the 9 in the expansion. So just as a double check, did our final answer have the x to the 9? Yes. And we figured out the number in front. So if we just sort of, since we started this question halfway through, sort of do a review of what happened, right? We were asked to find the term that contained the x to the 9. We have our formula for terms in a binomial expansion. Problem, we don't know k. We don't know which term it is. So our solution is, oh, if you don't know k, probably need to find it. And the way that we find it is we plug everything into the formula, and we know that whichever term it is will be something x to the 9. Then in the formula, and I'm just going to take out a sort of like a yellow pen to circle, this is our only hint. So we're really only concerned about things that affect the x and its exponents. The rest of the stuff that I didn't circle will all affect this number out in front. And so if we temporarily ignore everything that affects the number out in front, which is all of the coefficients, and just think about the x's and their exponents, well, this x squared to the 9 minus k becomes x to the 18 minus 2k. And this x to the k would have an x to the k in your denominator. Exponent rules say when you divide with the same base, you subtract. So we get x to the 9 equals x to the 18 minus 3k, and that tells us those two have to be the same. We can now solve for k. Now, that being said, this method that I just showed you would be how you would have to do it if the exam said you have to do this algebraic. Sometimes the exam doesn't include that algebraic part, and a lot of students use sort of a guess and check again. Okay? Because the reason I call it guess and check again, because if you just guess something at random, now I know that I'm going to really try hard. I'm not going to guess 3, because I know that that's the right answer. I'm going to guess 5. If I guessed 5, do you see that this 9 minus 5 would be a 4? And you would have x squared to the 4, which would tell you if k equals 5, then you would get x to the 8 on the top. And if this was a 5, I would get x to the 5 on the bottom, which tells me I would get x cubed. What do I want? I want x to the 9. That kind of tells me that I want more numbers on the top and less numbers on the bottom. Well, what controls the numbers on the bottom is the k. So if I want less numbers on the bottom, for my guess again, I'm not going to go bigger. I'm not really guessing in the same way now. I'm sort of strategic. And if some people would just go 1 less, and then they put 4. Well, this is a 5. This gives me x to the 10 on top and x to the 4 on the bottom. Like, oh, x to the 6, but I'm getting closer. And a lot of people find just this guessing and checking actually much faster than the algebra. Because it's not like k is ever going to be 2.7. K has to be a nice number. If you're going to find term 7, it's got to be a nice number. So that does come up a fair bit. And you might be able to, and there's like guess really quickly. And there's some questions, especially on your pretest for this unit, that I would definitely say you could just look at it and figure it out without doing any algebra really quickly. So it's nice to have that as sort of an understanding and a background. We're going to do one more difficult question, because when I listed the difficult questions, talked about last term, middle term, we just did one with term contained. Now we're going to do one that involves a constant term. So this is what it would look like. Find the constant term, and some of you on your exam are going to put your hand up when you see this question, and you're going to say, Mr. J, what does this mean? What is the constant term? And the only thing I'd be able to say on the exam is remember when we did it in class and I underlined it in orange? And you'd be like, yeah? Okay. Yeah, I know, but I don't remember. I'm like, well, then you can re-watch this video and make fun of yourself at this moment. Take some time. You're re-watching this video. You weren't paying attention in class. You should make fun of yourself. Okay? Find the constant term in the expansion of, and this time I'll use 5x cubed minus 2 over x 15? No, to the 12. 15 might work too, but to the 12. So we have to go back to definitions in grade 9. What's a constant? A constant in an expression is something that has no x's, no variables. In other words, we could think of it just like the last question. We're looking for the term with x to the 0. Because x to the 0 is 1, and that would get rid of the x's. So I go to my formula again, my tk plus 1 formula. Here, I'll rewrite it out in green here, just so we have it. This is on your formula sheet. And we know that there are no x's, so I'll represent that there's going to be some number. And then the x has to be canceled out completely, x to the 0. Our n is our exponent, so that's going to be 12. Again, we don't know k. So if I write out the same instructions problem, we don't know k. What do we need to do? We need to find k. A is your first term, so that would be 5x cubed to the 12 minus k. And b is negative 2 over x to the k. And just like I circled in yellow last time, x's and their exponents are the only hint you have. I can write it in blue. The strategy we temporarily ignore all the numbers in front. So if we did that, we're going to have x to the 0, because we ignore the number in front that we don't know, equals, well, here in my numerator, x cubed to the 12 minus k will be x to the 36 minus 3k, because exponent to an exponent means you multiply. And we have x to the k on the bottom. X to the 0, if we do our exponent laws, and again, I'll do it algebraically first. Once you get a single power on both sides with the same base. So 0 would have to equal 36 minus 4k. That's not hard to get the 4k on the other side. Divide by 4. And we find it is term 10. If the question said, which term is the constant term, we would be done. If the question says, find the term or find the constant term, we haven't found it yet. We just know where it is. So now, find term 10. And we go to our formula, and if we're using term 10, obviously k would be 9, so this will be 12, choose 9. Our first term was 5x cubed to the 12 minus 9, and our second term was negative 2 over x to the 9. Again, we'll put brackets for each of these. I'm going to simplify each one individually. I keep them in brackets to remind myself I have to multiply, especially with negatives there. Sometimes if you forget the bracket, all of a sudden you think you need to subtract. 12 choose 9 is 212. 12 minus 9 is 3, so 5 cubed is 125. X cubed would be x to the 9. Negative 2 to the 9 would be negative 512, and x to the 9 would be x to the 9. And you know things are going well when this happens, right? Your x's all cancel out, leaving you with no x's. That's going to be a constant term. And now we just need to multiply all of these numbers together. And sometimes in this unit, you get very big numbers. Negative 14,080,000. In section 8.6, you can also circle the question 9. They're practice questions like this.